Next, a step-by-step explanation of what is a film capacitor is based on the below points. Film capacitors are also known as a polymer film capacitor, plastic film capacitor, or film dielectric capacitor. It means film capacitors are electrical components that store energy using a thin plastic film as the dielectric. Film capacitors are also known as polymer film, plastic film, or film dielectric capacitors because they use a thin plastic film as the dielectric material between their plates. This plastic film acts as an insulator and is key to how the capacitor stores electrical energy. Different names simply highlight the same basic design based on the plastic film dielectric. Film capacitors are capacitors which uses a thin plastic film as the dielectric. The dielectric is a very thin plastic film made through a precise stretching process. This material is essential for insulating the capacitor plates. This film is made extremely thin using a sophisticated film drying process. Simply, film drying process means this is a specialized technique is used to reduce the film's thickness to the required dimensions. This process allows for the film to be made extremely thin, which is a crucial property for its function as a dielectric in capacitors. Once the film is manufactured, it is metallized or left untreated, depending on the properties of the capacitor. It means after the plastic film used in capacitors is made, it can either be metallized, means coated with a thin metal layer, or left untreated. This choice depends on what electrical properties the capacitor needs. Metallized film allows the capacitor to be self-healing and compact. Untreated film, often used with separate metal foil, gives better performance for high current or high voltage applications. So, the treatment affects the capacitor's size, durability, and performance. Electrodes are then added and the assembly is mounted into a case which protects it from environmental factors. It means after preparing the film, electrodes are attached to yellow electrical connection. The whole assembly is then placed inside a protective case which seals the capacitor from moisture, dust, heat, and other environmental factors that could affect its performance or lifespan. They are used in many applications because of their stability, low inductance, and low cost. Why film capacitors are widely used? High stability means they maintain consistent performance over time, even under varying temperature and voltage conditions. Low inductance means their internal structure allows for fast response in high frequency circuits, making them ideal for AC signal filtering and switching power supplies. Low cost means they are relatively inexpensive to produce, especially in large quantities, making them economical for mass production. There are many types of film capacitors, including polyester film capacitor, metallized film capacitor, polypropylene film capacitor, polytetrafluoroethylene film capacitors, and polystyrene film capacitors. The type of film capacitor names indicates the dielectric material. Polyester film capacitor, where dielectric material is polyester. Metallized film capacitor, where dielectric material is a thin layer of plastic film coated with a metal layer. Polypropylene film capacitors, where dielectric material is polypropylene. Polytetrafluoroethylene film capacitors, where dielectric material is polytetrafluoroethylene. Polystyrene film capacitor, where dielectric material is polystyrene. Each type of film capacitor, depending on performance needs like stability, loss, and tolerance and cost. The core difference between these capacitor types is the material used as the dielectric, and the proper dielectric must be chosen according to the application. It means the main difference between these types is the dielectric material used. The right dielectric must be selected based on the specific application, such as temperature range, voltage, frequency, and stability needs. Next, we discuss about the advantages of film capacitors. First one, high accuracy and stability. Film capacitors maintain their capacitance value with minimal change over time and under varying operating conditions, ensuring consistent performance in circuits. Second one, long lifespan and reliability. Film capacitors are durable and resistant to aging. They can operate for many years without significant performance loss, which is why they are used in industrial and high reliability equipment. Third one, low ESR. It means low equivalent series resistance minimizes energy losses and heat generation during operation, resulting in higher efficiency and performance. Fourth one, high voltage and surge tolerance. Film capacitors can withstand higher voltages and surges compared to some other capacitor types, making them suitable for applications with voltage fluctuations or transients. Fifth one, current tolerance. It means they can handle a wide range of current levels, making them versatile for different circuit requirements. Sixth one, non-polarized. Unlike electrolytic capacitors, film capacitors do not have a polarity and can be connected in either direction without affecting their performance. Seventh one, good thermal stability. They maintain their electrical characteristics across a wide temperature range, ensuring stable operation in various environments. Eighth one, high insulation resistance. Film capacitors offer high resistance to electrical leakage, minimizing energy loss and ensuring reliable operation. Ninth one, suitable for high frequency applications. Their low equivalent series resistance and low equivalent series inductance and ability to handle high currents make them well suited for high frequency circuits. Next, we discuss about the disadvantages of film capacitors. First one, larger size. It means compared to other capacitor types like ceramic or electrolytic capacitors, film capacitors can be larger for the same capacitance value, particularly at higher capacitance values. Second one, cost. It means film capacitors, especially those with specific features like high voltage or high temperature ratings, can be more expensive than other capacitor technologies. Third one, limited current surge rating. It means while some film capacitors can handle high surge currents, especially film or foil types, metallized film capacitors have limitations in their ability to handle large currents due to the thin metallization layers. Fourth one, lack of self healing. It means while some metallized film capacitors offer self-healing properties, others like film or foil types do not. Once damaged, these non-self-healing types may fail permanently or degrade in performance. Fifth one, not ideal for small form factors. It means due to their size limitations, film capacitors may not be the best choice for applications where space is extremely limited and very small components are needed. Next, we discuss about the applications of film capacitors. First one, power electronics. It means film capacitors are used for filtering, snubbing and desealing applications. Second one, audio circuits. It means film capacitors are used for filtering and coupling in audio circuits. Third one, lighting ballast. It means film capacitors are used for ballast for fluorescent lamps and other lighting applications. Fourth one, snubber capacitors. It means film capacitors are chosen for snubber applications due to their ability to withstand high voltage and current transients. Fifth one, high frequency applications. It means film capacitors are used for radio frequency circuits, switch mode power supplies, high speed digital circuits, telecommunications, and medical equipments. Sixth one, renewable energy. It means film capacitors are used for solar inverters, wind power systems, power conditioning systems, and energy storage systems. Seventh one, industrial applications. It means film capacitors are used in heavy duty equipment like motors and industrial controllers. Film capacitors are reliably long lasting performance in demanding industrial environments. The image depicts the construction of a film capacitor, a type of capacitor that uses a thin plastic film as its dielectric material. Where plastic film. This is the core of the capacitor, acting as the dielectric material that stores electrical energy. Where two-sided metallized plastic film. The plastic film is coated on both sides with a thin layer of metal, which acts as the electrodes of the capacitor. Where metal contact layer. This layer provides a connection between the metallized film and the external terminals. Where terminal. These are the external points where the capacitor connects to a circuit. This is our brief explanation of the film capacitors.